So now we're on to lesson 3, and lesson 3 is about standard form. This is our third form that we're going to be talking about as far as linear equations. And just to get you going, we're on page 39 is where we're going to start for notes. Remember that the practice is posted in Schoology so that you can be ready to do that after we've gone through some notes. So let's just refresh our memory. We have had two other types of equations. We've had slope-intercept, and slope-intercept is y equals mx plus b, where m is the slope, b is the y-intercept. We've also had point-slope form. Point-slope is y minus y sub 1 is equal to slope times the quantity x minus x sub 1, where m is the slope and y sub 1 x sub 1 is the point. So today we're going to talk about standard form. So let's look at this next question. It's kind of an interesting one anyway. Jay makes a playlist of 24 songs for a party. Since he prefers country and rock music, he builds a playlist from those two types of songs. So he has listed different playlists, and he has picked a way that he could do that. And his playlist consists of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 country songs. And he has, of course, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 rock songs. And that makes sense because it's 24 songs. So that's what he chose for his playlist. But there's lots of different ways we could do it. So another one might be that we choose 12 country and 12 rock because we have to have a total of 24. Or we might choose 9 country and 9, would that be 15 rock? Okay? These are all different ways that we could have a playlist. You've made playlists before. That's what we're talking about. Okay, so now on the next one, we're going to look at how we could graph this. Now, this graph is not in your book, and I realize that. You can sketch it if you want to. But what I did is I just drew, I just had a grid, and I'm going to plot some of those points that we had. So one of the one that he had was 13 country. And of course, then 11 rock. I think that's what it was. Let's look back for a second. 13, and then 12 and 12 and 9 and 5. 15. Okay, so let's just plot those points. So we're going to go 13, let's go 12 and 12. That's the easiest one first. So 12 and 12, that's the point right there. Okay, 12 and 12. And then we have a 9. So remember, each line is 3. So here's 9 and 15. Okay, then we go 13, which is what he chose, which is just a little beyond that, and 11. Okay, so we could choose lots of different ones, but they all have to add up to be 24. So if you want to right now, you choose some and plot those points. So I'm going to choose 3 and of course 21. So 3, 15, 18, 21. Okay, now you'll notice that no matter what you choose, you're going to have a line that goes through all these points. Okay, and that's what we're going to be talking about today, is this kind of sets us up for standard form. So then it says, can you use a line, so we just drew a line, to find other points. So anything on this line is going to work. So this point right here, whatever that might be, it looks like, what, 15, about 17, and 7. Let's see, 17 and 7 is what that point is, because that still gives me 24 songs. So any point on this would be part of the solution. So then it asks, why is it helpful to use a graph rather than a table to answer your questions? Well, if I have a graph, I can just kind of look at it and see what is happening. So back on this line, I could just look at the graph and say any points on this line would be a solution. Whereas in a table, I have to produce it. I have to actually plug in the numbers and find it. So the table, the graph is helpful, quick to look at, quick to determine, because you can just look at. quick to look at solutions. Okay, and the table, you'd have to generate it. Now, a disadvantage, so this is advantage, and a disadvantage of a graph is not as accurate. And we were even doing that ourselves. We're going, oh, that's about 14. Okay, graph is not as accurate as a table. A table is going to be exact. And the advantage for a table, or the disadvantage for the table in this first question, is that you just have to generate the numbers. So this next question we're going to look at gets into standard form even more, and I'll explain that. This is in the additional packet. This is on the additional packet. It's after page 12. We know that. So after page 12, you're going to find this additional packet, additional problems. And we're going to just write an equation for this. Now, if you're at home and you don't have that packet, you can just kind of see what we're doing. We're going to have some additional problems that you're going to be doing in your book that will do some of these same things. So Hannah wants to spend $150 on the music festival tickets. So that's going to be her total. Reserved seats cost $25. General seats cost $10. How can you represent this equation with a linear equation? Well, this is where what we can actually do. If I'm in a linear equation, I can have two variables. So I can have an x and I can have a y. So I can make the x the reserved seats, and I can make the y the general admission seats or tickets. Then my equation is very simple because I'm going to have $25 times however many reserved I have, plus $10 times however many general I have. And that's going to be equal to my total of $150. So this equation is what is called standard form. Okay, but this is going to be something that you're going to be doing. I know on your test you're going to be doing things like this. And it's not real advantageous right now, other than we can graph it and find solutions. But when we get into systems of equations in a couple chapters, this is what we're going to be doing. And you're going to see that is so much easier than having to define a variable in terms of the other thing. So this will come in really handy. Now this information, is it easier to find the x-intercept of the graph of the equation in part B using slope-intercept or standard form? Okay, so what was supposed to happen back here is they wanted you to take this equation, this is standard form, and then we could also find it in y-intercept form, in slope-intercept. So if I want to get it in slope-intercept, all I have to do, remember what slope-intercept is, y equals mx plus b. So in order to do this, I just have to get y by itself. So I'm going to take this equation, and I'm going to get y by itself. So first, I'm going to subtract 25x. So I get 10y is equal to negative 25x plus 150. Then I have to get y by itself, so I'm going to divide every single term by 10. And I get y is equal to negative 2.5x plus 15. So this is my standard form. We'll talk about more of that in a second. And this is my slope-intercept. And what the next question in your book is asking is if I had to find the x-intercept, okay, if I have to find the x-intercept, what do I need to do to find the x-intercept? That's right, I'm going to plug 0 in for y. Okay, so what that next question is asking, I'm going to take and write these two equations again. 25x plus 10y is equal to 150. Then the slope-intercept, y is equal to negative 2.5x plus 15. So what this is saying is it's easier to find the x-intercept of the graph of the equation in part B using slope-intercept or standard form. So which one would be easier? Well, to find the x-intercept, what do? That's right, I'm going to plug 0 in for y. So whenever I find an x-intercept, I'm always going to plug 0 in for y. So here, I would plug in 0 here, and I'd solve. Here, I'm going to plug it in, for y, and solve. And so they're asking which one would be easier. Yeah, what they're trying to indicate is that one would be a little easier to find your x-intercept because you're going to quickly get 25x is equal to 150 and solve for x. Where here you have to move the 10 over and then divide. Neither one of them are too complicated, but they're saying this is probably going to be easier. So let's talk standard form. What is standard form? Standard form looks like this. Capital AX plus capital BY is equal to capital C. And yes, it does make a difference. When you're indicating standard form, you want capital A, capital B, and capital C. What you need to understand is that A, B, and C are all integers. We learned about integers last chapter. Remember, integers are no decimals, no fractions. Okay? Positive and negative whole numbers. So no decimals, no fractions. So standard form, A, B, and C all have to be whole numbers. They can be positive or negative. Also, to be in standard form, you can't have both A and B. A and B are not both 0. One of them can be 0. A could be 0 or B, but not both at the same time. Now, the other one is not always required, and this is where some people say, yes, it has to be this, and some people say it doesn't. So A must be positive. There are some that say that A always has to be positive. Some say that it doesn't have to be. But this is standard form. And you could see how standard form has its advantages when we have to write an equation. Given information, if I'm going to write an equation, it's really handy. So if I had an equation in standard form, I might have 3x plus 4y is equal to negative 12. That could be an equation in standard form. Okay? Now, if I have 4.7x plus 5y is equal to 12, is that in standard form? No, why not? Because you can't have a decimal. None of them can be decimals. Good. So go to page 42 right now in your books. Go to page 42. And then read this question. Malcolm says that y is equal to negative 1.5x plus 4. In standard form is 1.5x plus y is 4. What is the error that Malcolm used? Concentrate on this equation. Write down your thoughts. Why is there a mistake with what Malcolm wrote for standard form? That is right. You cannot have a decimal as one of your coefficients. A coefficient, remember, is a number in front of the variable. You cannot have A, B, or C be a decimal. Okay? A, B, and C must be integers. So now we're going to graph. If we're given an equation in standard form, what we're going to do is we're going to graph using x and y intercepts. So what we need to remember when I find an x and y intercept, if I want to find the x-intercept, I am going to plug 0 in for y, exactly. And if I want a y-intercept, I'm going to plug 0 in for x. And then we're going to solve. Okay? So let's make a grid here. I'm just going to put it right here. Just kind of in the middle. Okay? And now we're going to find each of those x-intercepts. So here we go. If I'm going to find my x-intercept, I'm going to plug 0 in for y. So 4x plus 5 times 0 is equal to 10. Now I'm just going to solve this equation. This gives me 0, so I have 4x is equal to 10. Divide by 4, and I get x is equal to, what is that, 5 halves, so 2.5. 5 halves is also awesome, but I'm going to be plotting that point. Now that is a point, so that means that is a point 2.50. Let's do the same thing with our y-intercept. Find your y-intercept. Ready? Go! Hopefully you plugged 0 in for x. So then you divide by 5, and we get y is equal to 2. So this is the point 0, 2. So we're going to plot both of these points. 0, 2. There's our y-intercept. And our x-intercept is 2.5, so about right there. Now, the wonderful thing about this is it's pretty quick. The bad part about x and y intercepts, you make one little mistake and you have a totally wrong equation. And you're not going to probably notice that right away. That's all there is to graphing in slope-intercept. I mean, if I have it in standard form, I'm just going to find my x and y intercepts. Okay, now you're going to try them. So go to page 42. We're going to go to page 42, and we're going to graph this equation. Okay, so we're going to start off by just making our grid. Make our grid. and you're going to find your x-intercept, and you're going to find your y-intercept. Okay, ready, go. So if I want to find my x-intercept, I'm going to plug 0 in for y. And if I want to find my y-intercept, what do? Exactly, plug 0 in for x. And we're going to solve each of these equations. Go! So x is equal to 8, so that's the point 8, 0. Because it's a point, you should write it as an ordered pair. And then you're going to have 0, 2 for your y-intercept. So plot those 2 points. They're not always going to come out to be positives, just to let you know that. And 1, 2, 3, 4, 5, 6, 7, 8. So I didn't plan there. Next time, I'm going to find my x and y intercepts before I make my axis. Okay, good. Let's do the next one. So find your x-intercept. Find your y-intercept. I'm going to pause it. We're all going to do that. Go. So when you plugged in 0 to find your x-intercept, you plugged it in for y, and you found out that x was equal to 8. And again, that's a point, so that's 8, 0. And on the y-intercept, you plugged 0 in for x, and you found out that y was equal to negative 6. So that is a point 0, negative 6. So we're going to plot these. Now, I kind of waited to draw my axes because I have this and I have this. So I'm going to have to go further down. Okay, so I'm going to start up a little higher because I have y-intercept of negative 6. And I'm going to start over a little further to the left. So I'm just kind of strategically playing with those. 1, 2, 3, 4, 5, 6, 7, 8. Dang, still didn't get it. So let me try that line again. We're just going to move it over one more. And we're going to put it over here. While I'm moving lines, I should check. 1, 2, 3, 4, 5, 6. Yep, that one works. Okay, here we go. So I have my x-intercept, which is 8. 1, 2, 3, 4, 5, 6, 7, 8. And I have my y-intercept, which is negative 6. 1, 2, 3, 4, 5, 6. And then I draw my line. And I draw my line. Okay, but you could see one little mistake and your line would have been going in a totally different direction. So you just have to watch for that. Okay, so now we're going to talk about horizontal and vertical lines, and we've already referred to this somewhat. So we're going to go through it as if we are doing x and y intercepts. So look at 3y equals negative 18. If I want to find my x-intercept, I'm going to plug 0 in for y. Yes? So I get, well, I don't get anything. There's no x. So that one doesn't even fly. So let's find my y-intercept. If I'm going to find my y-intercept, okay, I'm going to plug 0 in for x. Well, that doesn't affect anything, so it's going to be 3y is equal to negative 18. Divide by 3, I get y is equal to negative 6. So my y-intercept is 0, negative 6. Okay, and I'm going to put it way up here. Oops, didn't mean to do that. I'm going to put my axis way up here, and this won't matter. Okay, and when I go to graph it, well, I have to go through negative 6, 1, 2, 3, 4, 5, 6. And I have no x-intercept. There is no x-intercept, right? So it's never going to touch this. So we know that our line is going to just be right down here. We also know that because we talked about it before. If I have an equation with one variable, equation with one variable. If I have an equation with one variable, then my graph crosses that axis and only that axis. Okay? And for you, hopefully you wrote that off to the side. Equation with one variable. If there's an equation with one variable, then the graph crosses that axis and only that axis. So let's look at B. We can do it by x and y intercepts, plugging in the 0. That doesn't seem to be too helpful. So instead, what we're going to do is that we're going to look at it and say, hey, there's only one variable. Which variable do I see? And you're going, I see an x. So if I see an x, that's the axis it's going to cross, and only that axis. Well, where does it cross at, though? That's what we have to find out. X is equal to 3. So 1, 2, 3, this is my graph. Okay, good. So that's horizontal and vertical lines. Hey, while we're here, what's the slope of a vertical line? Vertical line is undefined. That's right. Good. Now, if we go to page 42, if you want some additional practice, you can do that. So pause yours right now and do these two problems, and then we'll come back with the answers. Go. Did you get on the first equation that x was equal to 4? Okay. So if we have x is equal to 4, that is the intercept. This is the x-intercept, but we have to graph the line. If I'm going to graph the line, I go to 1, 2, 3, 4. Because it's on the x-axis, I only see one variable, so it's going to cross that axis and only that axis. Okay, looking at number 8, what axis is it going to cross? That's right, it's going to cross the y-axis. Now what you have to figure out is where is it going to cross the y-axis, and that's where you need that intercept, but you still have to graph a line. So, of course, that's going to be at -3. Here is my line. It crosses the y-axis and only the y-axis. Good. So for this one, given a linear equation in standard form, can you always find the x and y intercepts? Explain. Okay, so just think about that one. And your answer should be yes, because I can always plug in 0 for y to get the x, and I can plug in 0 for x to get the y. The other thing that is also true that I'll show you is if I take standard form. Let's go back to standard form for just a second. The other thing I can do, I don't like teaching this shortcut, and it's one that I just learned. If I want to find the x-intercept, so there's my standard form, I'm going to write it again. Well, if I plug in 0 for b, for y, see how that just drops out? And if I'm going to solve for x here, I'm going to divide through by an a. So I get that the x is equal to c over a. So that will always be true. So yes, you can always find an x and y intercept. Same is true if I'm going to do the y-intercept. If I plug in a 0 for x, notice that my a's drop out, so in order to find y, I'm going to divide by b. So my y-intercept is always going to be c divided by b. So for those of you that like those little shortcuts, feel free to use it. I want to make sure you know both. Great. Okay, so on this next one, there are word problems, and usually like, oh my gosh, no, not word problems, yuck. But these are actually pretty nice, okay? These are not too bad, just stay with me. Tamira is making trail mix. She has $40 to spend. This is in your additional packet because I wanted you to be able to refer to it too. So go to your additional packet right now, okay? And she has $40 to spend. That's my total. And she's going to mix together almonds and cashews and wants about the same amount of almonds. So about the same amount of both. How can she determine how many pounds of each kind of nut to buy? Well, let's first write the equation. So with almonds, oops, you can't see that color. With almonds, okay, it's $8 per pound. So your equation would be 8 times A. And then with cashews, it's going to be 10 times C. And that's going to be equal to my total. Okay, so we have lots of different ways we can go about solving this. But because we only have one equations and we have not learned systems of equations, what we're going to have to do is we're going to have to graph this. So we're going to find our x and our y intercepts and we're going to graph it. So if you go to your additional packet, hopefully there will be a grid right there. And we can be using that. So I'm just going to pick a grid from something else and I'm going to be using that, but there will be one in your packet. The reason standard form is so nice is because look how fast it is to set up that equation. Okay, so let's solve for our x-intercept and our y-intercept, and then we're going to graph it. So my x-intercept, I plug 0 in for y. Okay, so this is my x, this is my y. So my x-intercept, I'm going to plug it in for c. So I have 8a plus 10 times 0. Okay, so my x-intercept, let's just call that x, it makes it easier, 5, 0. And then my y-intercept, I'm going to plug in 0 for a, for my cashews. So this is the point 0, 4. Okay, so let's go find a grid. So you're going to go to the grid in your packet. I didn't have a grid when I was doing this presentation, so I just went back to another one. So just ignore all this stuff. We've already done those notes. Okay, so now I'm going to use this grid right here. And think about it. If I'm buying almonds and cashews, am I going to buy a negative amount? No. So I'm going to choose my axis to be right down here. And I'm going to make that my x and this my y. Now, I can go all the way up to 40, right? Think about that. So if I had, I can have my x and y intercepts are 5 and 4. So that's my x and my y intercept. So I'm just going to use that, and I'm going to say my x-intercept is 1, 2, 3, 4, 5. And since they're just small numbers, I'm just going to do that. My x-intercept, remember, was that almonds or cashews? That was almonds. Okay? So my x-axis was almonds. And then this is cashews over here. And because they're such nice little numbers, I'm just using each line is worth 1. So I'm going to put a 2 here and a 2 here to indicate each line is worth 1. Now I'm going to plot that y-intercept of 4. So that's right there. And so my graph looks like this. So then what the question is it says, how can she determine how many pounds of each kind of nut to buy? She wants about the same amount. So let's look at our graph again. So if we want it to be about the same amount, we might pick something like right here. That would be 2.5, okay, 2.5 of the cashews, and 2 pounds of the almonds, because see, that's right there. So 2 pounds of almonds. Okay, that would be an option. Another option might be that we go a little further this way, and maybe we pick, oh gosh, maybe 2 pounds. So right there, what if we picked 2 pounds of, if I'm doing this, I have 2 pounds of the cashews. And now we're just going to kind of approximate, what would that be? There's 3, so I want to say like 2.75 of the almonds. Now we could find out more exactly what that is, because we could plug these both into the equation is what we should do. So if I plug in 2 cashews, what is y going to be equal to? And it has to equal out to 40. Okay, so that's the reason I'm just kind of approximating them for now. Okay, but you can kind of see from your graph you want it to be close together, and I'm just picking numbers that are close together. So if you want them really close together, maybe we could pick this point right in there. Well, what is that? It's kind of hard to tell, but you get the idea, okay? And we're just approximating on this anyway. So I was saying we were approximating, but if we're not, let's plug it in and see what happens. So I'm going to just say that we have 2 pounds of cashews. That was one of our options. We're just going to plug that in and see what happens. So we have 8a almonds plus 10 times 2 is equal to 40. And we're going to actually solve for a to find out exactly how many almonds. So 8a plus 20 is equal to 40. We're just solving this equation. Divide by 8, and we get a is equal to 10/4. So 4 goes into 10 twice, carry the 2, 2.5. So 2.5. So that one we're pretty accurate on. Let's see what happens when we plug in the 2.5. And we could have also done that same thing. If you look back at the graph, we could have plugged in for A and then solved for C. But we're going to pick one and then solve for the other one. So if I have 8A plus 10 times 2.5, and on a test you would want to find exactly, and that's the reason I went back to this, just in case it shows up on a test. I want to make sure that you see how to do it. Calculator. 1 and 7/8. So hold on. That turns out to be 1.875 pounds. Okay, you're not going to be buying that at a store. They're not going to measure out 1.875 pounds. So maybe we should have picked a different number there. But if we were doing a pure math problem, that's what we would have picked for almonds. Okay, so I just wanted you to pick a couple and then see what happens. So let's go back for the graph for just a second. So maybe what I should have done is picked whole number points and said, if this is my whole number point, okay, and maybe use that, and picked instead that I would have had 4 pounds of cashews, 4 pounds of almonds, because I'm down here on almonds. Okay, so maybe picking different numbers and then plugging the other one in would have been a better idea. So then the problem that's in your book on page 41, we use the same information, that it's 8 almonds and 10 for the cashews. But now we can spend $60. Okay, so now our equation looks like this. And it says, how many pounds of nuts can she buy if she buys only cashews? So think about that. If she only buys cashews, that means I don't buy any almonds. So that means almonds is 0. So you're actually finding your y-intercept here. So cashews, I'm going to buy 6 pounds of cashews if I'm only buying cashews. What if I'm only buying almonds? Well, do that same thing. We're going to not have any cashews, so C is going to be 0. So we get 8A, we divide through by 8, and we get A, because this is 0, and I have 60 divided by 8, and we get 7.5 pounds of almonds. What about a mixture of both? And this is where a graph would be really helpful. Find out those x and y intercepts, and it's going to be between that. And you could probably even kind of approximate, because think about your graph here. I'm just going to sketch it. So for the almonds, it'd be about 7.5. That's my x-intercept, and my y-intercept is 6. So your line would look like this, and that's just a rough sketch. So you might want to go in between there and pick some different values, and you can say, what if I wanted about right there? Well, that's about 3 pounds of almonds. So what if I had 3 pounds of almonds? Okay, I could plug that in and find out what that would be. So plug that in and solve that equation. Okay, go. So if I picked 3, because I'm just looking at a sketch, I came up with if I picked 3 pounds of almonds, I'm going to have 3.6 pounds of cashews. Okay, which is great if you're in a math class, but if you go to a store and ask for 3.6 pounds of almonds, they might kind of look at you strange. Okay, but that just gives you an idea on how you can do it. So now I'm on page 42 of your book, and it's talking about okay, so read the problem. Deandra has $12 to spend on a mixture of green and red grapes. What equation can she use to graph a line showing the different amounts of green and red grapes? So all you have to do is write an equation. Okay? So look at this. Nothing difficult here. Don't overthink this. We have 3 green grapes plus 2 red grapes is equal to $12. And then what you just want to do is just make sure that you indicate, hey, which one's X and which one's Y. And it really doesn't matter. It honestly does not. Your line might look different, but your values would be the same. But this would be an equation you could use for that. Okay? Good. So this is a question that I thought was a very interesting one. And if you want to write this down in your book someplace, that might not be a bad idea. So write down this equation, this problem right down here. And if I remember, I'll try to put it in your packet. So which values of A, B, and C will AX plus BY equals C be a horizontal line? That's going to be our key through this point. So let's just sketch that. If I have a horizontal line, okay, so here's my horizontal line. And a horizontal line, okay, so horizontal, this is a horizontal line. And it's got to pass through the point 47. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Let's say that's right here. Blah, 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 blah. Okay, so we have a line that looks like this. Okay? So what do I notice? Well, I notice, because it's a horizontal line, I don't have any x-intercept. So if I don't have an x-intercept, that means A is going to be equal to 0. Okay? Then what that means is that if I would have to go through that point right there, and that's the point 0, 4, my y-intercept has to be 4. So if I plug in, if I have by is equal to 4, because that's what I have to do, because my ax would be gone. If I have that, then what could b be in order to be 4? Well, b could be 1, and c could be 4. See how I do that? Because I have to get my y-intercept to be 4. The important one is that a has to be equal to 0. So I could have also had that b is equal to, we'll say, 2, and c was equal to 8. Because if I plug that in, I have 2y is equal to 8. I can divide through by 2, and I get y is equal to 4. So what you have to pay attention to is that horizontal line, and I really recommend sketching it first. Okay, just wanted to show that to you. Thought it might be helpful. It will be in your additional packet. Good. So now it's time to either go work on that homework or finish up whatever in lesson 2.3 that you did not have done for that assignment. So if you have questions, you know where to find us. Thank you.